Okay, we're back for part 3. So where we left off last was, let me find this. Here we go. So let's go here, and I'm going to go through these different categories and start knocking them out per category, and we'll cycle through them in that direction. So we have the this prefix sum, find the highest altitude. So this will be our next one. Let's come in here to the code, and we're going to create part 3. And give me a second here just to copy my sort of boilerplate. Set a test here. Nope. There we go. My fingers are cold. It's hard to get going with typing. So now let's do test. fn test. Find highest altitude, and it's number 1732. So for the input here, the output's going to be 1. Assert EQ1 is going to be solve highest altitude 1732 of this input. There we go. Now it's failing. Pub fn solve altitude, and we're getting an array of I32s, and we're going to return an I32. Expected one of. Okay. Values. Okay, now we're building and failing. So biker goes on a road trip. Oh, the altitudes are deltas, and we want to know the highest altitude of a point. So this is just having an accumulation. So values iter, used to into iter, reduce. The first value is 0, right? So this is actually fold, right? Isn't fold the opposite, or the difference of the reduce function? Let's see here. So we actually have we actually values fold this directly, right? Nope. Init takes 2 arguments, an initial value and a closure with 2 arguments, the accumulator and an element. Okay, so we're going to initialize it to 0, and we have the accum and value. I think it actually goes like this. Yeah. So it expects this to return something expected on I32. So ACC plus V, I believe. Oh, we don't actually want to fold this because we want to know what the altitude is at every point. So let's do this. Iter map So we do need a sort of reduce function. Let me look up what those are. Rust iterator, Rust iter, fold, reduce, accum. What are they all? I actually want to accumulate stuff at each point. So I don't want reduce. I don't want try reduce. That's not what I want. All, any, fine. You know what, we can do this. Let mute accum equals 0. And value, and we are going to return this as and I think that's actually just it. There we go. So if we look at our function here, I'm going to mess. My desk is a mess. Let's do another one here. For this array, the altitude they say is 0. It's weird. Let's see what prints. Minus 5416. Minus 4, minus 7, minus 9, minus 10, minus 6, minus 3, minus 1. The highest is 0. So we do start with 0. That's the thing. Is it's like we want to have. We do need to start with 0. It's not concat. It's what's the method to concatenate? It's always called something different, and I don't remember what it is. Chain, that's what it is. That's what I want. So this should give us the right value. Good. Let's submit this. Run. Submit. Good. Okay, it does look like I am the only one to ever submit this to Rust. It's disappointing. Find the difference of two arrays. Okay. What number? 2215. Okay. Output is going to be that. Solve diff to arrays 2215, and we are giving it nums1 and nums2. Close pub diff array. What do we call this? Nums1 is a slice of an I32, and nums2 is also a slice of an I32, and we're going to return a double vec of I32. I believe it just wants a two-dimensional array. Yeah. Whatever. N1 equal nums1. Let's do to do here so we can compile. No implementation for double equals. Okay. Okay. Now we're building. So in one is going to be nums1 iter copied collect into a hash set. There we go. Into, what's the real thing we have to do? Answer 0 is a list of all distinct integers in 1 which are not present in nums2. So let 1 not in 2 equal in 1 iter filter in 2 contains v not present. Yeah, I think that's correct. 2 not in 1 is going to be that. So now 1 not in 2 collect, 2 not in 1 collect. There we go. So this gets 2 and 2. So these are all that earn 1. These are all that earn 2. And I think we just need a not in front of this. Yeah, there we go. I'm not even going to bother adding more tests because I think this is just going to be right. Hash that's not found. Run, 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 run. Wrong answer. 1, 2, 3, 2, 4, 6. This is where syntax highlighting would help, or error checking. Accepted. Submit. This is an easy one. So I can probably actually use not a hash set, but a hash it's like a heap, right? Yeah, I'm not going to worry about that. Let's just move on to the next one. Removing. Hold on. Why are we not passing now? There we go. You are given a string S which contains stars. Okay, I looked at this one before. Removing stars from a string. There we go. 2390. So input is LeetCode. string stir, and we return a full string, right? Good. Okay, so okay, so just for fun, what category is this? Stack. Stack? Seems like this is a pointer sort of thing. So yeah, let's just do sort of a scan. Star position. We're gonna loop. While let some star position res iter position of C equals star. I think that way. We good? Good. Okay. Remove position equals. We also remove the star itself, right? Yeah. Star position saturating subtract 1 and res remove position if remove position is not equal star position, we just remove it twice. And then we return res. Why do we get are these supposed to be in sorted order on that previous one? The difference of two strings. Integers unless may be returned in any order. Okay, it's just that my test is not testing this right. I mean, it is testing it right. It's just I'm just taking this out because I don't want it to fail sometimes. So solve remove stars does work. Erase is going to get all zero or an empty string. There we go. So let's submit this. Time limit exceeded. So there's just a ton of stars here. So this is in the stack section. So let's change this. So that's not cares. And we're going to just walk through this one by one. So let's do next care equals move, and that's not next question mark. We're just going to do this for now. Good. If C equals star, you're really removing the one before it. This is probably marked as easy, isn't it? Medium. So you can see they just have all of these stars. Stars A, stars C. So what we need to do is just not add it. Yeah, so we're going to do this with a sort of an index. So we have this now, vec of cares. So our next care is going to be let index equal 0. New size. And we're going to move again. If next C is s.get index plus 1, if next C equals star, then actually this will be a loop. If it doesn't equal star, this C is going to be s.get index. I think this one's not going to return the last one. Doesn't equal sum of that. Then let's see. Otherwise, it is a star, and we need to just bump up index. I think just past it might be incrementing to I think then this is just going to be so that do it. We need to move. You haven't been watching me. LE. Um, So if this is a stack sort of thing, then we see L, push on the stack, CE, push on the stack, CE, push on the stack, C star, we pop off E. We see, oh, yeah, let's do that. Just because it's a stack sort of thing. And then for C and S dot cares, if C equals star stack pop, otherwise stack push C stack collect. I think this is what they really want us to do. Let's put this in. There we go. Okay, now we're going. Stack Q, number of recent calls. So you have a recent counter class, which counts the number of recent requests within a certain time frame. Initializes a counter with 0 requests. Request for what? Int ping int adds a new request at time t, where t represents some time in milliseconds, and returns the number of requests that happened in the past 3,000 milliseconds, including the new request. Specifically, return the number of requests that happened in the inclusive range Okay. Input is, I don't know, this recent counter. Ping, 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 ping. Okay, weird. Test, recent counter, 933. Do we have a new? Yeah. And then we're going to call ping 3 times. Four times. 1, 2, 3, 3. On RC, ping with 1, 100, 3001, and 3002. times is going to be, I think I could just use a vec of I32s and ball counter ping self T is I32 returns an I32. Okay, so that failed like I expected it to. So we're going to self, of course you need a mutable reference, self times push T and back times is self times reverse. Back times is back times take while time ago is going to be T minus 3000 inclusive range. Okay. Well, T is greater than equal time ago. And we want count. Yeah. So, I don't like that. I mean, there's not really a queue. There sort of is, but it's just not a good test. 45 milliseconds. It's a longer time. I don't know what I would do differently with this. Except maybe like get rid of older times. I could do that. And then just always return the length. So what if this is a vecdec instead? Right now it's going to wow. V is greater than equal time to go. That's probably what they want me to do. So in this case, we're just taking out anything that we don't want. And then our test is a lot faster. Okay, we'll go with that. Okay, let's look at the next one. Linked list. This is one of those where, like, your linked list in a definition for a singly linked list node, delete middle. You're given the head of a linked list. Delete the middle node and return the head of the modified linked list. So I don't even really have to do this straight in the code because I don't have yes, I do. Linked list. Let's start off with just this. self. Next, replace it. Box new node. I think that's what we have to do. And then hello.
How are you?
I'm fine.
Where did you go?
We went to the park.
Ooh.